All right, so we're going to move from a really guess and check style of factoring to something that may help us factor some of those difficult problems with the ax squared plus bx plus c just by keys in the problem. It's called perfect square factoring, and there are two types of perfect square factoring. One is the sum of squares, where you notice instead of saying ax squared plus bx plus c, I have a squared x squared plus bx plus c squared. This means that the leading coefficient and the constant term are both perfect squares, or numbers that can be obtained by multiplying a number by itself. Likewise, there's a difference of squares where the b term doesn't exist, so I have a squared x squared minus c squared. Notice again the b squared doesn't exist, and the leading coefficient and the constant term are both perfect squares. We're going to take and factor these now. So another way to state a difference of squares is say, well, a squared minus b squared, or the first term squared minus the second term squared, is equal to a minus b times a plus b. Likewise, we could say here we're looking for two terms that multiply to x first and that multiply to 36. Now, normally to multiply to 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now, rather than guessing all those, we could say, okay, well, the first term is a perfect square, the second term is a perfect square. I'm going to guess, and 9 times out of 10, you're probably going to be right, that I'm using this as a perfect square. So the square root of 36 is 6, and then I need a negative, so one has to be positive, one has to be negative. And since this is a 1x squared, then I need two numbers that multiply to 36 and add to 0, and these two do that. This was a pretty simple example. We'll look at more difficult ones as we go along. So this one's a little more difficult. We notice we have a coefficient in front of the x squared term of 49. Normally we'd have to list the factors of 49 and the factors of 25, but this is a perfect square. And so is 25. What multiplied by itself is 49. That's 7. And again, these are guesses. I'm going to check this by foiling after I'm done. And what multiplies by itself to get 25? 5 and 5. I need a negative, so one's a positive, one's a negative. Take a look at the FOIL. This is 49 x squared minus 35x plus 35 minus 25. And you'll notice those middle terms go away, and I have 49 x squared minus 25. Now, again, 9 times out of 10, this is going to work. You'll notice here, again, I have perfect squared terms, numbers that are obtained by multiplying a number by itself. This is 4y and 4y, 9 and 9, but I have a w at the end, so I'm going to say 9w and 9w. Plus and minus to multiply to the negative 81. There's 16 y squared minus 36 yw plus 36 yw minus 81 w squared gets me 16 y squared minus 81 w squared. Done. These are a little more difficult because you'll notice that what multiplied by itself gets you x to the fourth. Well, that's not x and x, but if I say x squared and x squared, those two multiplied together are x to the fourth. 9 and 9 are still 81. And then you'll notice again, this is our first in what is to be a preview of the next lesson, something that actually continues to factor. This is not a sum of squares or a difference of squares. This doesn't factor, so I leave it as x squared plus 9. This is a difference of squares, so I have x plus 3, x minus 3. And if I were to FOIL this out and then FOIL that with the x squared plus 9, I get back x to the fourth minus 81. Likewise, this term is a little more complicated. What multiplied by itself is x to the fourth. We just did that, x squared and x squared. Now you have to think to yourself, what multiplied by itself gets you w to the 12th? Well, in thinking about it, that's w to the sixth and negative w to the sixth. And we look at this and say, well, that's not a sum of squares or difference of squares. We leave it the same. The second term is actually a difference of squares. What multiplied by itself is x squared, x and x. What multiplied by itself is w to the sixth. That's w to the third and w to the third. Again, plus and minus, and then that's done. We can solve these just like we have all of our other problems. You'll notice perfect squares at the two ends. It looks like a difference of squares. So 5d minus 10, 5d plus 10 equals 0. Solve. If they multiply to 0, then 1 has to equal 0. So I'll add 10. 5d is 10. Divide by 5. D is equal to 2. Subtract 10. 5d equals negative 10. Divide by 5. Get d is equal to negative 2. So now we're going to look at sums of squares. Remember we had a squared x squared plus bx plus c squared. You'll notice the first coefficient and the constant term are both perfect squares. Before, once again, we'd have to list the factors of 25 or 1 and 25, and then 5 and 5, list the factors of 9, 1 and 9, 3 and 3, and then go through that whole guess and check process. But hopefully we're going to be able to simplify this process by saying, hey, I think I've got a perfect square factoring going on. Let's spend a second to check to see if it works. So what multiplied by itself is 25x squared. That's 5x and 5x. What multiplied by itself is 9. That's 3 and 3. They both need to be negative since I have a negative middle term and a positive end term. And now just to check, I'm going to FOIL this out. 25x squared minus 15x minus 15x plus 9. Notice 25x squared, like terms add to negative 30x plus 9. It checks. And a lot of times, I'd say 90% of the time, if you have perfect squares at the end, it's going to factor that way. We'll take a look at these and go ahead and check while we do it. Again, what multiplies to 49? That's 7w and 7w. What multiplies to 36? 6 and 6. Additions across the board. FOIL, 49w squared plus 42w plus 42w plus 36 gets me 4w squared plus 84w plus 36. And that beats the guess and check of factors of 49 and the factors of 36 because there's quite a few. Again, 2y, 5 and 5, both need to be negative. You'll notice 4y squared minus 10y minus 10y plus 25 gives me 4y squared minus 20y plus 25. And with these we can also take and solve the equations, taking that risk and saying those look like perfect squares at the two ends, so I'll say 5b and 5b, 4 and 4. Jump the gun there. Going to be negatives because I have a negative middle term. It's equal to 0. Just check by foiling. There's 25, there's 16. Then notice negative 20 is negative 40, so that checks. So now I have 5b minus 4. And rather than write it twice, I'm just going to write it once. Add 4. Get 4 is equal to 5b. And by dividing by 5 to both sides, we get b is equal to 4/5. When I repeat my answer, we call this a double root. We'll talk about why we call it a root later.